Bill McArthur's first encounter with NCSSM was actually in 2006 when he actually downlinked from the ISS and chatted with NCSSM students. As you can see here, this is actually the same room you're in right now. It's very cool.
And kind of as how we got to know Mr. McArthur is from our Avi and I's Conrad Spirit of Innovation project. Our project was designing a sleeping pod that would be useful in the International Space Station or in space. Essentially, the problem with sleep is that the sun rises every 90 minutes on the International Space Station, and the circadian rhythms of astronauts often get messed up. And so we used red and blue lighting to kind of stimulate sleep and awake. And we wanted to see how we could better improve our design. And so we interviewed 3 astronauts, one of them including Mr. McArthur. And 3 things that he told us that were pretty interesting was that it's really noisy in the ISS, and how crucial a little bit of private space could be sometimes. Also, that spinal elongation causes backaches. On Earth, you could be your height, and when you're in space, you'd probably be 2 or 3 inches taller because gravity no longer has forces pushing down on your spine. But this stretches out your muscles, as you could imagine, and causes backaches for some or most of the astronauts. And he told us that in order to alleviate this, astronauts would often hug their knees or the fetal position, and that would kind of smooth out the backache.
So we decided to, so after Conrad, we decided to focus on that, studying the spinal elongation, which we thought was very interesting this year through the Hunch program.
So our Hunch program actually began this year in October last year, around October, second trimester. It began as a special study option. We had, I think, 12 students in there. And we started with the idea that we wanted to model spinal elongation in space in a microgravity environment. And so we had the idea that we'd build a model of the human spine, which was incredibly complex. We spent all of second trimester, a couple hours a week, prototyping and coming up with designs, what would work best. And we had to take into account our intrinsic muscles that go all along your back, not only just the gravitational weight force of your body pushing down on your spine in a 1G environment, but all of the muscles inside us that are putting different forces in different directions on our spine. And so we spent a lot of time researching, a lot of time prototyping. Our first design began as a little clay model. And then beginning of this trimester, we began work with just us 4, actually building the model that you can see here. What we ended up doing is utilizing an actual model of a human spine, which is just a kind of plastic. We had to remake the discs that go in between your vertebra using memory foam and electrical tape. And we curved our bar to model like the curve of the spine in your body. And as I said, we wanted to model the actual elongation in zero gravity. So in a 1G environment, this is, you can see here we have the green therabands that go vertically all along the sides of it, which mimic the intrinsic muscles that go vertically along your back. And we have up here, you can see these black boxes are also force sensors, which are hooked to different places along the spine, these Lexan plates. And those will register different changes in force vertically as it's in a 1G environment or a microgravity environment. So when we're on a plane testing this, we can actually model in real time the changes in force of the spine. We also have 2 piezoelectric strips on this level and this level. Piezoelectric strips generate voltage when they bend, and as they're mounted laterally to the spine, they'll bend in really minute increments, generating a voltage that we can model. Any questions on the design? Oh yes, we also have 2 accelerometers mounted on the very bottom plates. We took data using 2 different lab quests, and so to each lab quest we had 4 inputs, and one of the accelerometers went to each LabQuest. So when we had a stream of data being recorded, we could see that in direct comparison to accelerometer data. So for example, if we were going from 1G to 2G to 0G, we could see a difference in our data as it corresponds to a change in gravitational force. Now, any questions on the design?
Okay. So we got in a plane on Wednesday after packing all our bags and taking this guy apart. And he includes a lot of screws, nuts and bolts, and a bunch of Lex and really clunky pieces. So we had to check that in, and we hoped that it wasn't going to break at all. But I mean, it was all disassembled. So then what? Oh yeah. So then when we got to Houston, we traveled to the Johnson Space Center, and we had our hotel, and we woke up at the crack of dawn and got to Johnson Space Center at 7 o'clock in the morning to get a lay of the land. And yeah, I mean, we weren't sleeping on these trips, so yeah, we had some work to do. So when we got there, we had a tour of the facility, and we got to go to a hangar where there was actually some maintenance going on with a plane, and we started to get to work. So then we figured out that we had some major modifications to do because we weren't going to be able to secure it into our glove box. We have a very specific space constraint with this design, and we had to share our box with another team. So we had to be very careful about the amount of space we took up. So we brought some of it back to our hotel to work on the weekend, and we had to go and fix our TDP? Yeah. We had to keep everything together, and we even had an astronaut look over our design here, and he's one of several people who looked at our box and made sure that everything was safe. As you notice, there's a bunch of blue tape everywhere in here, and they're all supposed to make sure that the edges aren't going to cut us when we're in the box, when we're in 0G. And we also had the entire framework foamed so that it was going to be able to pass inspection. So do we have a picture of that, by the way? No, we don't. Darn. So here we are on flight day, and Avi will explain what we did there.
Right, so on the microgravity flight, it's known as the weightless wonder, but it's also known to some people as the vomit comet because the way that the flight works is it goes in several parabolas, and while you're going up, you actually experience more than normal gravity on Earth. You experience almost 2 Gs. Then you have a period of about 30 seconds where you're in free fall, and that's where you have the 0G experience, and then the plane goes down again, and you experience greater Gs. So because of that motion, we had to take medication for motion sickness, and it's called scopolamine, and fortunately none of us threw up, which is great. And then we have some pictures of our flight, and you can see we are in fact in 0G. Yeah, and we were actually working on our experiment. It was kind of hard to control your body while you're in 0G, but this is actually when you're in greater than 1G, so you're pinned to the floor.
It's on its side.
Yeah, but Mr. McArthur, I'm sure, has experienced great periods of 0G, and so we're going to move on and introduce him. He's actually a North Carolina native. He was born in Laurinburg, and his hometown is Wakulla. And so he graduated from Red Springs High and got his undergrad from West Point and his master's from Georgia Tech. And then he went to, he joined the Army, and he went to the aviation school, and he's a test pilot for the Naval School.
Yeah.
and he finally became an astronaut in July of 1991. Right now, he's the Director of Safety and Mission Assurance for NASA's Johnson Space Center in Houston, where we were. And he's had 4 space flights, and he's logged more than 224 days in space. That's more than a school year total, including 24 hours spent walking in space. He's flown on 4 space shuttle missions, commander and International Space Station science officer. He's the 12th crew to live and work aboard the ISS, and he returned to Earth in April of 2006, completing his mission in 189 days.
So let's give a hand to Sir McArthur.
Thank you very much. Do a little quick reconfiguration here. See if the miracle of modern technology works. Yes, it does. By the way, let me see, where are my NASA colleagues? This is a stage. I see their steps over there and their steps over here. I don't like heights, so I think I'll come down to the floor. There's a story. I was in Greensboro in 2007, a stage a little higher than this, and I left the stage ungracefully at the beginning of my presentation, and I got to finish the presentation while the paramedics were trying to decide how serious my injuries were, and instead of being able to do a Q&A at the end, I was on the way to the hospital. We're not going to do that. Okay, I would like to correct one thing. I flew on 3 space shuttle missions, and then the 4th mission was on a Russian rocket. And that's kind of important for a lot of reasons. To me personally, it's important because it's been one heck of an adventure. And it was really rewarding to be able to see how another space program tries to achieve the same mission objectives we do. Tonight, because the real purpose of being here is a program called Destination Station, and the Destination Station is on display at the North Carolina Museum of Natural Science. And so I'd like to focus on my last mission for a couple of reasons. One, because space station is orbiting the Earth right now. There are 3 people on board. It has a normal crew of 6. This past Friday, half the crew returned to Earth after a 6-month mission, and next month, 3 astronauts will fly up there. 2 Russians and an American will fly up there to return the crew to its normal complement of 6. The space station has had a permanent crew since November of 2000. So for almost 12 years, there has been a permanent human presence in space. I was talking to some 5th graders today, and it dawned on me that in their entire lifetimes, there has never been a single moment in which human beings were not in space. And I would argue that that is what we as human beings have become. We have become a spacefaring race. And so I'd like to talk to you not about visiting space, but about living and working in space. What does a ticket to fly in space look like? Any idea? No ideas. Well, you know what an airline ticket looks like, right? So what does an airline ticket have on it? Flight number? Your name? And you know, a ticket to fly in space looks a little bit like that. I was the commander of Expedition 12, and there's Roman numeral 12. And there's my name. And a little different is our tickets are made of cloth, and we sew them onto our clothes and do all sorts of cool things like that. And this was a flight shortly after, a few years, 2 years after, about 2.5 years after the Columbia accident. February 1st, 2003, the Space Shuttle Columbia broke apart when it re-entered the Earth's atmosphere, and we tragically lost 7 very dear friends of ours in that accident. And so we vowed that we would no longer fly the space shuttles until we knew what happened, what caused the accident, and we could have some confidence that it wouldn't happen again. And we discovered something interesting when we did the back of the envelope calculation. We discovered that, absent the space shuttles, we could only keep enough food, air, water, clothes on board to support 2 people. And so I went up as part of a 2-person crew. And you are probably pretty familiar with the Cyrillic alphabet. It's the alphabet used in the Russian language. And so this name is not pronounced the way we would pronounce it here in the United States, but it's pronounced Tokarev. My crewmate was Russian Air Force Colonel Valery Ivanovich Tokarev, hero of the Russian Federation. He's about the same age I am. We've both been married about the same length of time, a long, long time. Both have 2 children. He had a grandson at this time. 6 months after we landed, my first grandchild, a little girl, was born. So we have a lot in common, and including our early military careers. Have you ever heard of the Cold War? Of course you have. And so as lieutenants, we were studying sort of the same thing, how to kill people. The problem is we were trying to learn how to kill each other. So this was a neat thing. Instead of considering the evil empire of Russia as a big threat, it's interesting that in space exploration, we have become really good partners and good friends. So, as I mentioned, the space shuttles were not flying, so we flew on a different type of spacecraft. This is a Soyuz, and this is our Soyuz being transported on a train from the assembly building out to the launch pad. And it gets out there, and it's immediately then lifted upright, unlike the space shuttle, which would be transported out to the launch pad in an already in an upright configuration. The Soyuz is erected once it gets to the pad. This launch pad has a name. Gagarin Start. Start means launch in Russian, oddly enough. And it's named after Yuri Gagarin, the first human being to leave Earth's atmosphere, the first human being to fly in space. Yuri Gagarin flew on April 12, 1961, 51 years ago. For 51 years, people have been flying in space. I get asked, this is very reminiscent of the time in Greensboro when I got this stupid little pointer in the middle of my screen and I have to go get it. So, wait, there are only 2 of us on the ticket. So I guess I could be, the backup crew member doesn't go out to the launch pad with us. Maybe we had a stowaway. I'll talk more about that in a few minutes. So, what's it like to launch on a rocket? It's a blast. It's really cool, I got to tell you. I mean, you know something exciting is going to happen, and you also know that no turning back now, buddy. Ride's really smooth. Here you can see Valery in the center seat. I'm over in the left seat, and the ride it's really smooth going uphill. We go from the surface of the Earth. Our speed is just the rotational velocity of the Earth at that point. And we have to achieve a speed of 17,500 miles per hour to attain orbit. And there we are, we've gotten on orbit and we're really happy. And who is this guy? He and I were at the Museum of Natural History in New York the other day, and the ticket taker looked at him and said, "Are you Clint Eastwood's brother?" That's what he looks like. This is Dr. Greg Olson. Greg is a New Jersey businessman and scientist. And he must be pretty good at each, because he started companies to build his inventions, and then he would sell those companies, and he had enough pocket change to pay the Russians $20 million so that he could fly in space with me. Okay, all right. He paid $20 million to fly in space, and I was just lucky to be able to get to fly with him. There you can see Valery and me. Nice cozy, isn't it? So do you think you could spend 6 months in space? No, okay. Well, the good news is we only spend 2 days in the Soyuz, and it is pretty cozy, but we can go up into an orbital module, a kind of little bubble, a little egg-shaped module on top, so we have a little more room once we get on orbit, but it's not like the space shuttle. The Soyuz is sort of like an MG sports car or a Mazda Miata, a really simple little sports car, nothing fancy. It carries people from point A to point B. Maybe a suitcase in the back, not much. Space shuttle is more like a Mack truck. Lots of power, big trailer in the back, can carry lots of cargo. Everything, it's got hydraulics and pneumatics and really sophisticated. That's the space shuttle. So we spent 2 days orbiting, then we caught up with the space station. This is how it looked when we got there. And by the way, on my third space shuttle mission, one of my partners and I installed this antenna. That was pretty cool. Okay, and just notice there is only one big set of solar arrays on the space shuttle in this picture, and this is what it looked like in the fall of 2005. And guess what we found when we got there? Well, didn't I tell you that there's been a crew permanently on the space station since 2000? So there were people on board. Here you can see Sergei Krikalev in the foreground, who now holds the world's record for the most time spent by a human being in space, over a cumulative over 800 days. Behind him is John Phillips from NASA. And so we spent about 8 days together, and then Greg returned to Earth with Sergei and John, and it's kind of funny thing, he bought the Soyuz that he came back on. Okay, it's on the USS Intrepid now. That's an aircraft carrier that's at one of the piers in Manhattan in New York, where the Space Shuttle Enterprise will soon be displayed. So after a week of those of John and Sergei showing us where they hid all the good food, those three returned to Earth and left Valery and me alone together for the next 6 months. Our first task was to do something I really like to do, and that's go outside for a walk. Of course, it's a spacewalk, and that means you have to put on a spacesuit. And this is the American-style spacesuit called an extravehicular mobility unit, or EMU. And the interesting thing about the EMU is it was never designed to be used when there were only 2 people present, because it is very, very difficult to put on and take off without having someone help you. And if you've got the suit on, helping your buddy is not easy to do. But they told us if we could figure out a way to do it, they'd let us go outside. So here we are. I'm wearing the suit with the red stripe, and Valery's in the all-white suit. Our first task is to install a new camera on the outside. And this is a stanchion or a post onto which we're going to mount the camera so it protrudes out from the station and we can get a better field of view. Here we are translating to the furthest left end of the space station. Valery's carrying the stanchion, I have the camera, and notice these cables. They are protection in case you fall off. Why are you laughing? Why are you laughing? Why are you smiling? What, can you fall? Okay, yeah, we're weightless, right? So you can't fall. Oh, by the way, the camera and the stanchion together are about 200 pounds. Single-handed. Yes, sir. Charles Atlas. Look, okay, never mind. All right, it's weightless. It's got mass, but it's weightless. Okay, back to these safety tethers. They retract automatically into a reel. Any of you have a dog? Ever take the dog for a walk? Got a leash, dog runs out, comes back, the leash plays out, automatically retracts. That's sort of what we have. It's our leash, so that if we do float away from structure, we're not lost in space, but the reel will retract and pull us back to the anchor point. There you can see that the camera has been installed. This is the view. So these are radiators, and there's that antenna I pointed to earlier. It's kind of odd. There's a robotic arm. That's why we have the camera. So while we're inside, we can see the outside, and it helps us with robotic operations. We had to go do a task on the right side of the station, and so while I was waiting for Valerie to catch up, I quickly sneaked all the way to the end so that I could say I'd been as far left as you can go, as far right as you can go, and then we had to go to the top and throw away a piece of equipment, and then so we got to say on that EVA we had been to the far extreme, and so I didn't tell the ground, like I say, I just sneaked out to the end, looked over, "Ooh, I'm here, go back." But, as I mentioned, is a lot of work involved in going outside. The suits are hard to put on. It takes a lot of training while you're inside the space station. And so we don't do spacewalks very often. We do a lot of science on board. We do a lot of experiments. When Valerie and I were by ourselves, most of our time was spent just operating and maintaining the space station. As a matter of fact, to do science, I normally had to volunteer my Saturday afternoon free time for what was called Saturday Science. So every Tuesday, the ground would say, "This is what we would like for you to do on Saturday. Will you volunteer to do it?" And, well, since my wife is actually one of the was responsible for some of the payloads that are related to education. They found out if they gave me one of her activities to do, for some reason I couldn't say no. Oh, well. Okay, but this is something called the binary colloid, BCAT, binary colloidal alloy test. Oh, you all are smart, I know. So what's a colloid? You know, it's a liquid with stuff in it. It's got multiple components. Milk's a colloid, and that's a good analog, but milk's got a lot of things in it, not just two components. And, you know, if you keep milk under the right conditions, the colloid stays homogeneous. If you put it under bad conditions, leave it out on the counter overnight, starts to look, leave it long enough, and you got that kind of yellowish, oily film on the top, and then you got all the milk, the spoiled milk solids at the bottom. And why does it separate like that into layers? Gravity, you bet. And so we were looking at a binary colloid. It only consisted of two components to see how the phase, when it's separated, how that separation would manifest itself when there's no gravity to create stratification. So, big deal, but it's basic science. Basic science is important. There's really very practical research that's done. Here in Durham at the VA Medical Center, there is a doctor who has done research on bacteria on the space station. And they are very close to, based on that research, to developing a vaccine against salmonella. What does salmonella cause? Food poisoning. Anybody here ever had food poisoning? How was it? It was terrible, wasn't it? But thank goodness you recovered because you got good medical care. In third world nations, people may not be so lucky. It can be a fatal condition. Also, anybody hear of MRSA, multiply resistant Staphylococcus aureus, flesh-eating bacteria? You know, really dangerous bacteria that is resistant to antibiotics. The same professor has also done research with MRSA and has made a lot of progress to try to figure out ways to combat that bacteria. So that's the kind of research that we're doing. But we're also trying to learn how to keep people safe and healthy and productive while working in space. Here Valeri's working on an experiment called Matryoshka. Anybody here speak Russian? Говорите по-русски? Никто. Извините, пожалуйста. Okay. Matryoshka, anybody know what Matryoshka are? Everybody ever seen these Russian stacking dolls? Yeah, Russian stacking dolls, that's a Matryoshka. Did you know there is always an odd number? It's always an odd number because an even number is unlucky. 13 is unlucky. So, gentlemen, if you are in Russia and you want to take some flowers to a girl, dozen doesn't work. And if you're going to not give a dozen, don't go up one, go down one. Okay. So this is Matryoshka. It's to measure radiation in space. We don't have the atmosphere to protect us. We still get some protection from the Earth's magnetic field, but it is a radiation environment that is slightly more hostile than it is here on the surface of the Earth. And so Matryoshka had numerous slices, and in the slices were passive and active dosimeters, devices to measure radiation. So the good news is when we came back, they knew how much radiation we had been exposed to. Of course, by then, we had already been exposed to it, so I thought, okay, fine. Meals are really important. Oh, by the way, this is the most important tool on the space station. Would anyone like to hazard a guess why? You've got to open your food. You know, you tear the bags open with your teeth, eventually it hurts your teeth. Okay, just kidding. Anyhow, so that's why our scissors are important, because food is important in space, and we have really good food there. So this is Thanksgiving in 2005. Now, Valery, a Russian, is a member of the Russian Orthodox Church. I grew up I was born, I didn't grow up there, I was born down in Scotland County, southeastern part of the state. It was settled by Scots in the 18th century. And if you look at the history there, a lot of the people who left Scotland then were Presbyterians. So I happen to be a Presbyterian. So what we did is we said grace in our native languages, and that's what we would do at meals. We would use that as a cultural sharing time to talk about our upbringing and our traditions and our families. We had smoked turkey, mashed potatoes, green beans and mushrooms. You know, if you don't put quite enough water in the green beans, they sometimes don't quite stick together the way you want them to, and you have to be a little bit agile to get your food in the right place. Anyone recognize this? It's Santa's sleigh. Okay, this actually, if you turn your head over, this actually says in Cyrillic, Progress. The Progress is a Russian supply ship. It looks very much like a Soyuz, but doesn't carry people. And it arrived on December 24th in 2005, and it had our Christmas presents on board. What do you think would be good Christmas presents for an astronaut? Food? Water. I don't know. I know what you're thinking. No, it's water. Oxygen? Playing cards? Could be. And I was really anxious. We'd run out of salt, so I was really happy that they sent us up some salt. But anyhow, so yeah, you just have to think, if you're going to space, you have to take those things with you, or they have to be delivered. And it's okay on the space station, we can deliver them. We get deliveries several times a year from Progress. The Europeans have an automated transfer vehicle that one is docked to the space station right now. The Japanese have a vehicle called the H2, it's because they have a rocket called an H2, transfer vehicle, so it's HTV. They all deliver supplies. Next week, Monday, we're going to try to launch an American-built resupply capsule called Dragon. It's been developed by Space Exploration Technologies, or SpaceX. The Dragon capsule flies atop a Falcon 9 rocket, also built by SpaceX. SpaceX is a company founded by a gentleman named Elon Musk. Does anybody recognize that name? Does anyone have a PayPal account? Serious? Okay, good. Oh, all right, you're my wingman here. You're going to have to keep me. You're going to have to keep me from getting shot down. Okay, that's right. Elon Musk founded PayPal, and that's where his fortune came from. And so, anybody hear of a Tesla Motorsports, a Tesla sports car? Well, that's also an Elon Musk company. So that's how we're going to start supplying the International Space Station. Now think about this, though. You're going to Mars. If you want to launch supplies from Earth to catch up, lots of luck. Not going to work. So you got to take it with you. Not only that, you have to conserve. So let's talk about how we might conserve water on the space station, which we are doing. So you don't want to waste water. Oops. There's two meanings for that, isn't there? Okay. So where do we get water that we would normally throw away? Well, the air conditioner collects condensate, humidity out of the air. Another place for water? Urine, absolutely. And so we collect the wastewater, both condensate and urine, and we run it through a water processing assembly, WPA, and we turn it back into drinkable water. And yes, when it's working, we drink it. Now, we also do something else with the water. We put it through an oxygen generator system, which breaks the water down into its two components, hydrogen and oxygen, and returns the oxygen to the atmosphere. And what do you think we do with the hydrogen? We get rid of it. We don't want any of that stuff on board. Okay. Now, other things that you need to do to be healthy. You need to exercise. And so here you can see me running on the treadmill. This was at the same time folks were running the Houston Marathon and half marathon on the ground. And so I set the treadmill to run for 13.1 miles, a half marathon. It took me an hour and 54 minutes. Yeah, I know, it's kind of slow. But I told my friends on the ground, in an hour and 54 minutes, we went about 30,000 miles. That's further than around the earth. And so I told the folks on the ground, well, you ran a half marathon, but I ran around the world. Okay, now you heard about the student design for a sleep station. This was my sleep station, excuse me, on board the space station. There I was, my sleeping bag. There's my wife, kind of make it homey. Wife, daughter, son-in-law, other daughter. My little dog, Laika. Laika. Anybody ever hear of a dog named Laika? Who was Laika? 1957, the Russians launched Laika into space. And by the way, brushing your teeth is not real exciting. It's just like in space, just like on the Earth, except you spit your toothpaste out into a towel. Or you can swallow it. Have you ever read a toothpaste tube? What does it say about swallowing toothpaste? It says don't. Yeah, well, at least for 6 months you can get away with it. But anyhow, so yeah, Laika was the dog the Russians sent into space. First animal to fly into space, 1957. And shaving in space is kind of the same. By the way, we can't do product endorsements, but that razor does have 3 blades in it. Okay, got it. All right. Then in February, we had a neat opportunity, and that was to go outside again. This time we went in a Russian spacesuit, which really is a little better designed to put on by yourself and take off unaided. The airlock, or the hatch we went out, is actually blocked by this solar array. So here we are setting things up. And it's really important to move slowly and carefully so you don't lose your grip or something, or, oh wait, okay, that looks like a problem. But good thing is, we have that safety tether and it's gone. Okay. Houston, we have a problem. Well, okay, one of us was lost in space. I'm here. Okay. All right, well, we knew we decided to get an early jump on April Fool's Day, on April 1st. We had an extra spacesuit on board. So we filled it with dirty clothes and towels. And remember, I pointed out you couldn't see the airlock, you couldn't see the hatch that we went out. So we sneaked the spacesuit out and pushed it away and then keyed the microphone and went, "Help, help." You think they would have let us come back if we did that? Yeah, well, if they wanted the spaceship back, I guess they would let us come back. But that isn't really what happened. It was an experiment called SUIT-SAT, or Spacesuit Satellite, or Radioscaf. And so what we did is we attached a radio that transmitted on an amateur VHF frequency a message recorded by young people from around the world in their native languages. It was a message of world cooperation and brotherhood, and it orbited for 6 months. Now, remember I pointed out the picture of my little Laika, my little dog? Sadly, right before I left to launch, she passed away. And so we had her cremated. I took a tiny little Ziploc bag inside another tiny little Ziploc bag with some of her ashes, and I smuggled it on the flight from Houston to Moscow. Then I smuggled it on the flight from Moscow to Baikonur, Kazakhstan. Then I smuggled it on board the Soyuz up to the International Space Station. And I put her ashes in the left glove of the suit. And that was my farewell voyage for Miss Laika. She orbited for 6 months and returned and re-entered the Earth's atmosphere in September of 2006. Now, 17,500 miles an hour means we go around the Earth once every 90 minutes. 24 divided by 1.5, 16 times a day. See how math stuff works. 16 times a day. 16 sunrises, 16 sunsets. Wake up, go to sleep, wake up. Well, okay, don't do that. But Earth is beautiful. When people say, what's your favorite planet? Yes, we're standing on it. It's the only planet we know capable of sustaining human life. We need to take care of it. We see some pretty cool things when we're in space. We flew right through a total eclipse of the sun. We flew right through the moon's shadow being cast on the eastern Mediterranean. 2005 was the most active hurricane season in history. Hurricane Katrina. This is Hurricane Wilma, which was in the Gulf. Finally hooked around, lost a lot of strength when it hit Florida, but it was a massive, massive hurricane. Wilma, that's almost near the end of the alphabet. So what would happen if you ran out of letters of the alphabet? We go to the Greek alphabet, and so we started naming hurricanes that year using Greek letters. The last hurricane of that hurricane season was Hurricane Epsilon. Andes Mountains, down in the southern part of the Andes Mountains in South America. These are the Patagonian glaciers. And see, that's what we try to do when we're flying in space. We try to take pictures of the same area over a long period of time. And so I took these pictures. Other astronauts had taken pictures of the same area before. Astronauts since then have taken pictures. So that if you measure if you note the location of the leading edge of the glacier field, if the climate is cooling, the glaciers should advance. If the climate is warming, the glaciers should retract. Arawanga Crater in North Africa, 11 kilometers, 7 miles across. What might cause something like that? Meteor, comet, big rock going really, really fast, hits the ground, converts all that kinetic energy into heat, drills right down through the Earth's surface, gets the harder bedrock, liquefies it. It's like dropping a pedal in a bucket of water or in a pond. The liquid rock splashes up. As it solidifies, it creates these areas of harder rock near the surface. And so wind and sand erosion over time wears away the soft rock more rapidly than the harder rock that's been lifted up from lower levels in the Earth's crust. And so, how many times do you think this has happened? How about a lot? You can look all over our planet, and you can find evidence that the planet has been struck by big rocks. If it happens tonight, you don't have to worry about your homework. Of course, we have a lot more to worry about. So, you know it's going to happen again? If you look at a geologic time scale, we are going to get struck by a big rock again. Odds are it won't be in your lifetime. But it's going to happen again. And that's why Stephen Hawking, the famous British physicist, said the survival of the human species requires that we colonize other planets, because someday this planet will become uninhabitable. All right, food for thought. But I'm not losing sleep over it tonight. That's an interesting part of the world. Anybody recognize this place? Well, let's see. That is Cape Fear. The Cape Fear River runs all the way back up this way. Lake Waccamaw. Let's see. Wilmington is here. Got the Outer Banks going up here. Somebody here from Wilmington? Okay, good. Anyway, so that's southeastern North Carolina. And there you can see Cape Hatteras, and there's this nice sun glint. And the surface patterns of the ocean vary greatly, and you can really see that if there is sun glint. Back one. That's RDU. There's North, Durham, Raleigh. Of course, you know Raleigh isn't due south of Durham, so let's turn the picture around a little bit, and that's a better representation of how it looks. Cherokee, North Carolina. It's kind of interesting. Look at these interesting features here. I wonder if I've seen those before. Let me go back and see. Yeah, look. There they are. Does that look natural or man-made? You know, if it stands out and it looks odd, that's what you learn from space. If it looks odd, you ought to look at it really closely, because there's a high likelihood it isn't natural. So let's look a little closer. There it is again. This is where I was this morning. This is Fort Bragg, Pope Army Airfield, Simmons Army Airfield. And this is where the paratroopers at Fort Bragg, these are the drop zones that they parachute into for training. So, April 1st, instead of an April Fool's joke, we had another crew come up to join us. Jeff Williams, Pavel Vinogradov, Marcos Pontus, and they came, these two guys came to relieve us. Marcos, the first Brazilian in space, his government paid the Russians just like Greg paid his own money for Marcos to fly. And so here's our handover. Yes, those are Huggies, wet wipes. We use those in space. They're very convenient. Wash your hands, wash your dining utensils, wash your face. I kept them right outside my sleep station in case my eyes dried out at night, so I could moisten them up a little bit. So, Marcos, Valeria, and I got in our Soyuz, undocked, and it was time to come home. This is the descent module. This is the part we come back in. It's the only part that returns to Earth intact. The other two modules burn up on entry. In this next video, right at the very front, that little dot is our descent module. You can see the other two modules breaking up in the atmosphere. Nice soft landing? Well, hey, in the flying business, you know what they say. Any landing you can walk away from is a good landing, even if you're limping a little bit. Okay. There's our Soyuz. Wow. Scoured completely clean. Everything on the outside is burned off. Shortly after this, the space shuttle program resumed flying with the primary goal of completing assembly of the International Space Station. We completed that last year, and we saw the end of the shuttle program after more than 30 years of flight. And it was a pretty darn neat vehicle. Look at some of the statistics. Over 355 people flew on board the space shuttle. That's 70% of all human beings who ever went into space. It carried over 50% of all the mass put into space by anyone. It launched and serviced the great observatories like the Hubble Space Telescope. It was an amazing vehicle.
CGLS, pick up the clock on your mark. Let's copy.
And I'd like to share with you one of the last launches.
Mark. T-minus 5 minutes, go. Orbiter APU start.
MTD Houston flight, I have 2 seconds of train back hold remaining. 2 seconds.
Discovery OTC, close and lock your visors and initiate O2 flow. GLS is go for main engine start.
Thanks for all the work you did getting this ready to go, and appreciate all your work. And for those watching, get ready to witness the majesty and the power of Discovery as she lifts off one final time.
So, last July, saw the last space shuttle mission. Atlantis landed after flying 33 times. Discovery flew 39 times. And Endeavour flew 25 times. This is part of the shuttle legacy. Remember, I asked you to remember one set of solar arrays. That's all that we had on the space station when I got there. The space station is now bigger than a football field. It's almost 1.5 football fields side by side. End zone, the back of the end zone to back of the end zone. That's the length of the space shuttle. So is the mission accomplished? Of course not. We'll continue sending crews to and from the space station on board a Russian Soyuz. At the same time, there are 4 American companies developing spacecraft. The Dragon supply vehicle that Elon Musk's company is building is going to evolve it into a spacecraft capable of carrying a crew. Then we have Blue Origin's, Boeing, and the Sierra Nevada Corporation are all developing spacecraft. Now, we're not going to carry all of them to completion unless the private companies want to spend their own money. But at some point, NASA will begin to down select to the best designs, and ultimately we will wind up with 1, maybe 2 companies from which we can go buy flights to space, a lot like going and renting a car on a business trip. But that will only be to go to and from the space station. At the same time, we're developing the Orion multipurpose crew vehicle and the Space Launch System to go further. This vehicle will have the range to go to an asteroid or to return to the moon, or maybe eventually to even be the base system to go to Mars. So, the future. Well, I'm old. I'm looking forward to retiring in not too many more years. So, the future is whatever you want it to be. Do you have any questions? Go ahead.
One of our viewers on live stream asks, what are some of the tests you do in space?
What are some of the tests we do in space? We do a lot of basic human physiological tests. And so, we test for changes in the human body. We measure, for example, how the volume in your legs changes, because it's called chicken legs. Your legs get thinner in space. And of course, it's primarily from fluid shifts. A phenomenon we are very worried about right now is intracranial pressure. We've had some long-duration astronauts come back and their vision has permanently changed, at least has changed, and we haven't seen it return for a long period of time. And we think it may be due to the fluid shift, but we're seeing the pressure in many of the parts of the neural system, the brain, along the optic nerve. We're seeing changes that suggest elevated pressure. We're seeing the back of the eyeball is flattening, and so we're trying to develop diagnostic or equipment to be able to assess people on orbit when the changes actually occur. Every month I was up there, I had to get on an exercise bike and get hooked up to an EKG, and they tried to see how my cardiovascular system was changing. Other experiments, we grow crystals on orbit because we can grow much purer crystals, especially protein crystals, in the absence of gravity, and either bring them back to Earth to study, or there was an experiment I ran on board the space station called, I think it was PROMISE. It was protein crystal growth by 3D holographic imaging in microgravity on the ISS, on the International Space Station. And so we would actually grow the crystals in space, and we didn't have to take them back to the ground. The researchers could get all the data they needed through telemetry with the ground. So those are some of the things that we study. Right here. Конечно, обязательно, что вы говорите не очень плохо по-русски, если вы полетите на российском корабле. I said, of course, it's necessary for you to speak Russian if you're going to fly on a Russian spacecraft. The instruments are in Russian, the checklist's in Russian, the instructors speak Russian, the control center speaks Russian, and it's a lot of fun. You learn, when you study a foreign language, you begin to learn some cultural things, such as, have you ever heard that Eskimos have lots of different words for ice? Because ice is really important. Russians have lots of different words for bread. It's not just white bread, wheat bread, rye bread, dark bread. They have just separate, bread is not part of every descriptor of something that we would say is bread. Did I study Russian as an undergraduate at West Point? No, I studied German, and then I kept volunteering for an assignment in Germany, and the people who handle those things for the military said if he's volunteering to go there, he's up to something, so we'll send him to Korea instead. No, I started studying Russian as part of my second space flight because my second shuttle mission on Atlantis, we rendezvoused and docked with the Russian space station Mir, which flew on orbit from 1986 to 2001. And so I started studying Russian then, and then my third flight was up to the International Space Station, and we had to do work in the Russian part of the space station because there was no space station crew yet. So we had to do some training in Russia for that. And then right after my last space shuttle mission, they assigned me to be the NASA manager in Star City at the Gagarin Cosmonaut Training Center. And so I took 8 hours of Russian language training a week there. Excuse me. And then I took 6 hours of language training a week when I was in the U.S. And then, being in Russia, hop on a train, go somewhere, sink or swim. Another question. My father. My father was served in World War II. He served in World War II. He came back. He was in the Army Reserves for a while. He was a paratrooper, Green Beret, North Carolina tobacco and cotton farmer. Every time I see John Wayne, I think I'm looking at my dad. So he was a big influence. But he passed away when I was relatively young. He passed away when I was 13. And my mother remarried, and my stepfather was one of the kindest, gentlest men I ever met. And so, so it really was family support that made me, I think that gave me the confidence that I could go try to do things that a little boy who wore glasses from from the farms in Robeson County might not otherwise have done, because I knew if I failed, it would be okay. That to try to do something and not succeed was okay. Not trying was not okay. Sir?
What was your most memorable moment from space?
That is the hardest question that I ever get. What was the most memorable moment in space? And it changes from time to time. So the first launch is almost a relief. I mean, you're sitting on top of 4 million pounds of rocket fuel, and 6.5 seconds before liftoff, they light the first match. So you'd go, so that was fun? Well, it was fun from the sense that I first applied for the astronaut program in 1980. In 1990, 7 applications later, I got accepted. 1993, 13 years after I first got this harebrained idea that flying in space was something I could do, I finally was on the elevator going up, and so there was just this tremendous elation that, oh man, it's really happening. By golly, it's happening. I will be in space, and that can never be taken away. And then the first time you're weightless, that's just a thrill. I mean, I cannot tell you how much fun it is to be weightless for a long period of time, not just 30 seconds at a time. And by the way, Yes, everyone finally gets used to being weightless. But then another neat experience is looking at the Earth. This is a remarkable planet. It is so much variety. It is so cool. But then going outside, that's real space stuff. I mean, that is real Buck Rogers, 21st century stuff. Have you been to the mountains? Sure, North Carolina. You got to have been to the mountains. Stand in a cabin, look out the window, and look at the mountains. Hey, they're pretty. You're looking through a window. You go outside, and the mountains are all around you. That's what it's like going outside in a spacesuit. You have this panoramic visor, and space, instead of just being on the other side of a window, you realize it's all around you. And you also realize there's about that much stuff between you and vacuum. Other questions? Did I ever get cabin fever? No, I didn't. Fortunately, all my space flights, there was more room. And so my first space flight, we had a space lab module in the back, a big research laboratory where we experimented on ourselves and our 48 fellow crew members, the white rats. Second one, as I mentioned, went up to the Russian space station Mir, and so we got to go cavort in Mir, and it has like a whole lot of tunnel. It's sort of like a habit trail, you know, like little hamster tunnels all put together, and so you could go scampering around in that. And the Russian crew members were really fun. They were just great to work with. And then my third shuttle mission was up to the International Space Station, so we were working in the space station a lot, so we had a lot of room again. And then the fourth flight was on the International Space Station. It was about as big as a 3-bedroom house when I was there. Now, it's closer to a 5-bedroom house. Okay, other questions? Absolutely not. I was not in the Air Force, I was in the Army. About 50% of astronauts, you know, Air Force fly high, Army fly low, you know, whatever, you know, it's flying. About 50% of the astronauts are military. The other half are not. And so we employ test pilots, scientists, engineers, educators, doctors, people from all the technical fields. You hear sometimes referring to STEM education, science, technology, engineering, and math. Anyone who's interested in being an astronaut needs to really think about science, technology, engineering, and math. If you like doing let's see. School of Science and Mathematics. Okay, all right. So, all right. I think you're sold, so I'll get off the soapbox then. Yes, sir. How was it on the second flight? That's a good question. Thank you, Commander. What's your name? Paula? Nice to meet you. Nice to meet you. How was it on the second flight? It was better than the first. And there's some professional reasons for that. Like, let's say you go out and play tennis and you win the first match. Are you good or are you lucky? Wasn't that the question that Clint Eastwood asked in Dirty Harry? Do you feel lucky? Well, do you? Okay, never mind. And so you go, I think I did a good job. But when they tell you, okay, we're going to send you again, then you go, well, I guess I did well enough that, I'm really one of those people. So it was a great. The second flight was a great experience. Plus, got to go and see another spaceship. Got to go launch in one spaceship, dock with another spaceship, start learning to speak a different language, eat different food. Other questions? Right here.
So I heard in space there's a lot of taste distortions, so I have a lot of sauce in space. Do you ever do that?
Absolutely. Now, what we think it is with the fluid shifts, your nasal passage, your mucous membranes swell a little bit. And so your sense of smell is blunted. And your sense of smell is very important to how you perceive the taste of food. And now the dietitians on the ground don't add hot sauce, but we have things like Tabasco sauce and another hot sauce, wasabi paste. You know, it's really good to get your sinuses really fired up with that. The Russians would send up some fresh foods and things. So we'd get like actual cloves of garlic. Have you ever just bitten a piece of garlic? It's pretty sharp.
I was just curious, noticing you wear glasses, and I was curious if there was any special issues with that, like maybe on launch with the high Gs or in training.
And okay, wearing glasses. No, there's no issue. As a matter of fact, if you notice, I look down, the glasses don't fall off. They're actually very light. These have a titanium alloy frame, and they don't have hinges, so there are no screws to come out. As a matter of fact, even now, I never take these glasses off. I even wear them when I sleep. They're really great in a spacesuit because if you bump the side of the helmet, the glasses just kind of twist a little bit. The G's, maximum G for ascent is 3. No big deal. Entry in a shuttle is normally about 1.5, maybe 2 Gs. In a Soyuz, it's 4 to 8 Gs. It's not a problem. Maybe 1 or 2 more questions. Right here. Typical day on the International Space Station, Greenwich Mean Time. We wake up at 6 o'clock, have about an hour and a half to clean up, get dressed, go have breakfast. Then we start our day with a conference with the ground. Then we'll work on various activities, maintenance, cleaning, experiments till about 1 o'clock. Have lunch, and then from about 2 to 6, kind of the same activities as the morning. Somewhere in there, you fit in 2.5 hours of exercise. It's an hour and a half, if I remember correctly, it's an hour and a half of resistive exercise. And so we have machines that, you know, that have resisted bands and that put tension in cables, and you work against those. And an hour of aerobic exercise, either running or cycling. So then about 6 o'clock, you have dinner, you have a conference with the ground, and then from about 7 to 9:30, you'll begin to set up for the next day, clean up for bed, and in bed at 9:30. Bed, well, sleeping bag. What kind of equipment do we use to take pictures? And yes, you can see Durham from space, especially at night, lit up areas. We use right now various digital single lens reflex cameras. The one we really like on orbit now is the Nikon D3S. And we have just almost every kind of lens that you can imagine. The biggest lens we have is a 400 millimeter f4 lens, I think, or f2.8 lens, and we'll put a 2x doubler on it sometimes, so we have effectively an 800 millimeter focal length, and that's what we take for the really close-up pictures, but you know, it really tightens you down. Right here.
Can you describe like the feelings that you were experiencing and what was going through your mind the final seconds before you actually launched on your first flight?
First flight, please don't scrub, please don't scrub, please don't scrub. I mean, really, that was it. We'd scrubbed twice leading up to that, and we were ready. We were so ready to go. And it's interesting. If you launch, you can get out of your seat in about 8.5 minutes. If you don't launch, it takes at least an hour to get out of the spaceship. So, what happens when we get sick? Fortunately, we don't often get sick. So, but if we do get sick, there's someone on every crew trained to be a medical officer. I was an Army helicopter pilot. Yes, I got trained to pull teeth, to inject Novocaine in your mouth, to do stitches, to put in IVs, to do cardiac resuscitation, you know, with a defibrillator, and you know, by golly, epinephrine, here you come down the airway, things like that. So my advice to my crewmates always was, don't get sick. But we don't get sick very often because we're screened before we launch. We're kept in isolation before we launch, so we're not exposed to diseases. And if you're on board for 6 months and nobody comes up there, who's going to bring a virus up there? How are you going to catch a cold if there's no one there with a cold? And so we've been lucky. All right. My handlers are going to shoot me here. I'm waiting for the shepherd's crook to come from the side. And who should? Ira, are you going to receive this? Somebody asked about taking a picture of Durham from space. This is the Research Triangle area from space. There's RDU right there, so here's Raleigh down here and Durham up here. And so that's what you look like. Now, when I was on the space station, we did not have a camera capable of taking a picture like this. It takes something like the D3S with an effective ISO of like 102,500 or 102,400 or whatever it is, but we get some pretty cool pictures. Okay. All right, I do want to leave you with I'm going to leave you with a couple of thoughts. The first one is, the world has problems. You know that. You're smart young people. You know that we have problems. We worry about global climate change. We worry about overpopulation. We worry about the balance of energy consumption. Is the world going to run out of energy? Gosh, the U.S. economy, the whole worldwide economy has been struggling since 2008. So you know there are problems. Who caused those problems? Who caused those problems? Who caused the problems? Baby boomers. All right, he's got the right answer. You didn't. You're absolutely right. You didn't. And I resemble that remark, by the way. My generation is our gift to you is going to be a whole bushel full of problems. But you know, you have the ability to solve those problems. And in this group, I know you've actually started doing that right now, because I think all of you realize how important education is. And it's important to get the most out of your education that you can here. When you go to college, learn as much as you can, because what you learn today and what you learn over the next several years, those are going to comprise the set of tools that you have to solve some very serious problems, and they're going to require hard work, intelligence, and innovation. And I think you have all of that here. So I would just leave you with one thought, or maybe it's a question. Thank you very much.